Hello, today we'll be doing a presentation on the following question in Chm221. For question 1, the answerer will be Aida Adibah binti Muhammad. For question 2A, the answerer will be Nur Anisah Nadirah binti Muhammad Nizam. And for question 2B and C, the answerer will be Muhaimin bin Sulaiman.
Okay, for the question 1, first we separate with two parts, and first part is 100 ml, 200 ppm calcium nitrate, and 1.13 gram per milliliter density of calcium nitrate. Okay, first we calculate the gram of solute, which is nitrate ion, and the answer is 0.02 gram, and we calculate the gram of sample, which is calcium nitrate, and the answer is 113 gram. Okay, for the percent, we must calculate like gram of solute divided by gram of sample multiplied by 100, and the answer we get is 0.0177%. Okay, next, this is the part of question 1 with information given: 100 ml, 0.01 m of calcium nitrate, and 1.42 gram per ml of density. Okay, first we must calculate mole of calcium nitrate, and we get this answer 0.001 mole. And after that, we calculate mole of nitrate ion. After we calculate mole of nitrate ion, we get the answer 0.02 mole. After we get each mole, we can calculate weight of solute and weight of sample. For the solute, which is nitrate ion, we calculate with 0.002 mole multiplied by 62 gram per mole, and we get the answer 0.124 gram. And after that, we calculate weight of sample, which is 1.42 gram per ml multiplied by 100, and we get the answer 142 gram. After we get each gram or each weight, we can calculate the percent. Okay, for the percent, weight of solute divided by weight of sample and multiply with 100. Okay, after we calculate the percent, we get the answer, which is 0.087%. Okay, for the each given information, we can find that have some comparison for their percent. Okay, percent of nitrate ion in 100 ml 200 ppm calcium nitrate is 0.0177%, while for nitrate ion 100 ml 0.01 m of calcium nitrate is 0.087%. Okay, that's all for question 1.
So this is the second question. Questions 2A asks us to find precision and accuracy for both students and compare. To find precision, we have to find mean first. Mean for student 1 is 56.06, and use formula volume obtained minus mean value for precision. Precision for student 1 is 0.38. The mean for student 2 is 55.18, and the precision for student 2 is 2.1. So, precision of student 2 is higher than student 1. Okay, so let's move on to accuracy questions. To find accuracy, you have to use formula value obtained minus true value. The accuracy for student 1 is 5.3, while for the student 2 is 2.48. So, accuracy of student 1 is higher than student 2.
In question B, for student 1, we know that the question want 95% confidence for the question, and in the table for 95% confidence and the number of observation 5, we know that the table shows it wants 0.710. So when we calculate using A divided by W, we put in the value of 56.23 minus 56.08 divide by 56.23 minus 55.95, which we will get the value of 0.54. So the answer is acceptable because the Q table is larger than the Q experiment. Student 2, the question is still the same. So we know that we want 95% of confidence for 5 number of observation, which is, as we know, 0.710. And using the table that we are provided with, we can calculate the Q experiment, which is A divided by W, that we get 54.21 minus 55.10 divided by 55.71 minus 54.21, which we get 0.54, which is also accepted, which we can also accept the data because the Q table is larger than the Q experiment. For question C, we want to distinguish the difference of confidence level between student 1 and student 2. And to do that, we start with student 1. We find the mean value of 5 set, which is we put the 5 values divided by 5 and we get 56.06. And the degree of freedom is 4, so the T is 2.78. Using standard deviation, we use square root of 56.06 minus 55.95 squared plus 56.06 minus 56 squared plus 56.06 minus 56.04 squared plus 56.06 minus 56.08 squared plus 56.6 minus 56.23x squared divided by 4, which we get the value is 0.17. Continuing that, we know that the degree of freedom is 4 and the T is 2.78. Using that, we calculate confidence limit 56.06 plus minus 0.17 times 2.78 divided by square root of 5, which we get 56.06 plus minus 0.133. So from that, we know that the confidence interval stage is 56.193 to 55.927. For student 2, the mean value of 5 sets, we use the same formula as student 1, which we get the value for student 2 is 55.18. From that, we can now calculate standard deviation, which is S, and using the same formula as student 1, we get the value of for student 2 is 0.264, and the degree of freedom is 4 and the T is 2.78. Using that, we calculate the confidence limit, which is 55.18 plus minus 0.56 times 2.78 divided by square root of 5. We get 55.18 plus minus 0.734, which is the confidence interval of 55.914 to 54.446. That is all for our presentation. Thank you and have a great day.